Namaste to all of you. Present we are doing the binomial theorem. In this binomial theorem also we are doing present binomial coefficients. Binomial coefficients. We are doing binomial coefficients. Till now already I given basing on this binomial coefficients few properties already we discussed. Now already for example NC2. What is this NC2 value? N into n minus 1 by 2 factorial means 2 factorial means 1 into 2. NC3. What is this NC3 value? N into n minus 1 into n minus 2 by 1 into 2 into 3. 3 factorial means starting with the n reduced by 1 by 1 you can take 3 factors in numerator by 3 factorial like this. For example, if they will give NC4, what is the meaning of NC4? Starting with the n, take 4 factors in the numerator, n into n minus 1 into n minus 2 into n minus 3 by denominator value 4 factorial means 1 into 2 into 3 into 4. So this notation is very important. Even for further also we will use this notation. Just you can keep in your mind. Now related to these binomial coefficients, majority of the bits I completed. Now not majority, just introduction only we given. Next in the last class I given one example. A into C naught plus A plus D into C1 plus A plus 2D into C2 plus 1 plus A plus ND into Cn is equals to, what is the formula we given? 2A plus ND into 2 power n minus 1. Even for this one, proof is also I given. So A into C naught plus A plus D into C1 plus A plus 2D into C2 plus up to so on plus A plus ND into Cn is equals to 2A plus ND into 2 power n minus 1. Here one important point is there. If you observe A plus D, A plus 2D, so on A plus ND. If you observe A plus D, A plus 2D, these are in arithmetic progression. This concept already we given, arithmetic progression. Now basing on this, how they will frame the bits. If you observe here, like one example is there. Let me explain that one. Here the example is okay, example is not given here. Let me cross check one time. Did they given any example? I will explain one example so that you can understand easily how they will frame the bits basing on this. So here it is the example. C naught plus 3 into C1 plus 5 into C2 plus so on plus, here the last value they given 2n plus 1 into Cn equal to dash. This is the bit. Okay, listen here. Of course here C naught means indirectly 1 into C naught is there. So 1 into C naught plus 3 into C1 plus 5 into C2 plus so on plus 1 plus 2n into Cn is the value. So if you observe here, this is the example. What about this total value? Here if you observe 1, 3, 5 so on. These are in AP first of all. And A value. What is A value here? 1. A means first term here it is. Of course A is equal to 1. D value. What is the D value? 1 plus 2, 3. 3 plus 2, 5. So D value 2 is the value. So now basing on this theorem, what is the total sum will be? 2A plus ND into 2 power n minus 1. So which is equals to A value. What is A value? 1 is there. So 2 plus ND. What is the D value also? 2 into 2 power n minus 1. If you simplify common here 2 value. If I common 2 value, n plus 1 into 2 into 2 power n minus 1 means what is the value I can get? 2 power n is the value. So total value is given by n plus 1 into 2 power n. I hope that this is important point. If the coefficients, these are the coefficients, a plus d, a plus 2d, all these quantities are in arithmetic progression, then the directly formula is, this is the important formula, a into c naught plus a plus d into c1 plus a plus 2d into c2 plus so on plus a plus nd into cn is equals to 2a plus nd into 2 power n minus 1. I hope that this is clear for you. Next even basing on these binomial coefficients, one more example I will give. By listening these video lectures, you can prepare notebook. Okay. Now, listen, topic name is, here I am writing. One more example here it is there, like a theorem statement they given. Here the theorem is, if CR denotes NCR, then here the ability is C1 plus 2 into C2 into X plus 3 into C3 into X square plus 1 plus N into Cn into X power N minus 1 is equals to N into 1 plus X whole power N minus 1. Our aim is to show that this is the value. Okay. Here it is given that so if CR denotes NCR, then C1 plus 2 into C2x plus 3 into C3x square plus 1 plus N into Cn x power n minus 1 equal to, that is the value. Listen for this one. How you can simplify this value? Here we can do two methods. We can do two methods. First, one method I will tell you. What is the expansion of 1 plus x whole power n? Okay, if you observe 1 plus x whole power n expansion. If you observe 1 plus x whole power n expansion. What is expansion for 1 plus x whole power n? C naught plus C1 into x plus C2 into x square plus C3 into x cube plus so on plus Cn into x power n. This is the value. Of course, C naught means n C naught, C1 means n C1, C2 means n C2, like that. Then here you can add, we know that. Okay. Now if I differentiate with respect to x, differentiate with respect to x. If I differentiate with respect to x, here what I can get here? This is in the form, x power n form is there now. What is the derivative of x power n value? N into 1 plus x whole power n minus 1 is equals to C naught, that is the constant value. So constant value derivative 0. What about this value will be? C1 plus this value C2 into x square derivative, 2x is the value, plus next value C3 as it is x cube derivative 3 into x square is the value. By proceeding like this, here it is the value Cn into x power n derivative value n into x power n minus 1 equal to, directly you are getting this result now. Just cross check one time. C1 plus 2 into C2 into x plus 3 into C3 into x square plus 1 plus n into Cn into x power n minus 1 is equal to, what is the value will be? N into 1 plus x whole power n minus 1. That is the value. Okay, ma'am. So this is one more formula related to binomial coefficients. For example, one note, I will explain to you one note. For example, if x is equal to 1, this is the already we derived, this is the formula. Okay, this is the formula we are deriving from this one. By differentiating you will get this one. So in this expression total, in this expression, if I replace x is equal to 1, if I replace x is equal to 1, what I can get the value? Tell me. Here it is c1 only now. c1 plus, what about this value? 2 into c2 plus, next value 3 into c3 plus, up to so on. Wherever x value is there, if you replace x equal to 1 power some value 1 only. What about this value? N into cn, equal to what you will get? If I replace x equal to 1 here, what I can get, mom? N into 2 power minus 1. Got it now? So this is one more important point. C1 plus means 1 into C1 plus 2 into C2 plus 3 into C3 plus 1 plus n into Cn is equals to n into 2 power n minus 1. Instead of this whole value, you can write the whole value as sigma, listen, sigma r is equals to 1 to n r into cr is equal to n into 2 power n minus 1. So this is also important. Instead of writing the whole value, with the help of this sigma notation, this result I can write like this. Sigma r is equal to 1 to n r into cr is equal to n into 2 power n minus 1. So comparative point of view, sometimes directly they will ask this bit. Sigma r is equal to 1 to n r into cr equal to what is the value? What is the value, mom? N into 2 power n minus 1. Of course, by differentiating this result, you will get this is the value. This is given this theorem. Now in this expression, if I replace x is equal to 1, I can get this is the value. So here I am writing sigma r is equals to 1 to n r into cr is equal to what is value? N into 2 power n minus 1. So this is one important result. Keep in our mind. Now, okay, for this one more proof is also there, but maybe I am thinking that easily we are getting now. Okay, it is enough. Simply expansion this one, in that expansion differentiate, you will get the result. Okay, but here you have to keep in our mind this is the value. R into cr equal to n into 2 power n minus 1. Of course, the sigma notation is there. Next one more thing. After this one, mom, listen. One more point, note. Listen this one. What is the expansion of 1 plus x whole power n? 1 plus x whole power n expansion is given by c0 plus c1 into x plus c2 into x square plus c3 into x cube plus up to so on plus cn into x power n. This is the binomial theorem. Already we know 1 plus x whole power n is equals to c0 plus c1 into x plus c2 into x square plus c3 into x cube plus up to so on plus cn into x power n. That is okay. Now listen, mom. If I differentiate with respect to x, by differentiate, what I can get the value? Tell me. N into 1 plus x whole power n minus 1 is equal to c0 constant 0, c1 plus 2c2 into x plus 3c3 x square plus 1 plus n into cn into x power n minus 1. This is the value I can get. Once again I will differentiate. Differentiate again with respect to x once again. Then what I can get the value? N into n minus 1 into 1 plus x whole power n minus 2. Got it now? N is as it is okay. Again this is in the form x power n. What is x power n derivative value? N into x power n minus 1. Already n minus 1 is there. Changes to like this. Which is equal to this value will be 0. Here 2 into c2 plus 3 into x square derivative. This is the value you will get. Guess it, what is the next value will be? Here 4 into C4 into x cube will be there. If you differentiate 3 x square I can get plus 1 plus, what about the last value? Already n is there. Cn is constant. X power n minus 1 derivative n to x power n minus 2. This is the value now. Now if I replace, if x is equal to 1, if x is equal to 1, what is the value I can get? Tell me. N into n minus 1 into 2 power n minus 2 is equals to, what about this value? 2 into 1 into C2 plus 3 into 2 into C3. Of course, when x is equal to 1, 1 power any value 1 only. Next this value plus 4 into C3 into, 4 into 3 into C4 is the value. By continuing this process, what is the last value will be? N into n minus 1 into Cn. Now once again, this whole value with the help of sigma notation, how I can express? That implies sigma r is equals to, here starting with 2 only, 2 to n r into r minus 1 into, starting only C2 here, Cr is equal to, what is the value? N into n minus 1 into 2 power n minus 2. So this is also competitive exam point of view, one more important result. So sigma r is equal to 2n, this is the value. Can we take r is equal to 0? No, you can't take it. And here can we take r equal to 1? R equal to 1 means this is the value also 0. If you replace r is equal to 0, 0 you will get. Okay, and if you take r is equal to 1, this value will be 0. So initiation only we have to starting with 2. So this is the first one. Second one is sigma r is equals to 2 to n r into r minus 1 into Cr is equal to, what is the result we got? N into n minus 1 into 2 power n minus 2. This is the second point. This is the second important point, which is related to the binomial coefficients. I hope that these 2 points you can understand. So what is the first one? Sigma r is equal to 1 to n r into Cr is given by n into 2 power n minus 1. How you got it? This is the result. If you differentiate one time, you will get this result. If you differentiate 2 times this expression, this binomial theorem, you will get, this is the result. Sigma r is equal to 2 to n r into r minus 1 to Cr is equal to n into n minus 1 to 2 power n minus 2. These 2 competitive point of view, important points, keep in your mind. Okay. Next. Now here one example they given like this. Observe this one. Find the value of sigma r is equal to 0 to n r square Cr. This is the value if they will give. Find the value of sigma r is equal to 0 to n r square into Cr. For example, if they given like this, how you can find? This is the value. Find the value of sigma r is equal to 0 to n r square into Cr. Now listen, this solution part, what we can do? Sigma r is equal to 0 to n r square Cr. If r is equal to 0, what you will get? If r is equal to 0, 0 only, you're going to 0 into some quantity. So you can write this value as mom. If you expand this total value, 0 square into C naught 0, leave it. 1 square into C1 plus, this is the value, 1 square into C1 plus, 2 square into C2 plus, 3 square into C2 plus, sorry, C3 plus, up to so on plus what is the last value will be n square into Cn. This only you will get it now. Now our aim is indirectly to find this is the value. For this, listen this value. Sigma r is equal, instead of 0 I can replace 1 to n r square into Cr. Sigma r is equal to 1 to n. This value I can written as r square minus r plus r into Cr. Can I mention like this? Cross check one time. R square minus r plus r. I am adding 1 r and subtract the quantity. And now listen, which is equals to, here the first value, sigma r is equal to 1 to n r square minus r into Cr one value, r square minus r into Cr one value. Our next value, sigma r is equal to 1 to n r into Cr. This is the next value. Understand, mom? Here r square minus r I am written here, r into Cr I written here. Why I am writing here? You can understand easily. Now which implies sigma r is equal to 1 to n. This value I can written as mom, r into r minus 1 into Cr, first value, plus sigma r is equal to 1 to n r into Cr is the value. Now listen, mom. If I observe this value, r is equal to 1. If I replace r equal to 1, what I can get? 1 minus 1, 0. Na? So initiation from 2 only we can possible. Got my point now? Even if you take r is equal to 1. For 1, this value 1 minus 1, 0. Na? R value running from 1 to n. So if you replace r is equal to 1 here, 1 minus 1, 0. So leave the term. So directly this expression I can written as sigma r is equal to 2 to n r into r minus 1 into Cr first value plus next value sigma r is equal to 1 to n r into Cr is the value. Now listen, which is equal to, just now we get this value. What about this value? This is the value nothing but n into n minus 1 into 2 power n minus 2. Just this is the property, r into r minus 1 into Cr. R is equal to n is given by, this is the value I replaced. And next, r is equal to 1 to n, r into Cr value is given by n into 2 power n minus 1. Now listen, n into n minus 1 into 2 power n minus 2 plus n into 2 power n minus 2. Can I write like this now? 2 power n minus 1 is there. The 2 power n minus 1 value I can write like this, 2 power 1 into 2 power n minus 2. Not an issue. Between these two terms, I can common 2 power n minus 2. If I common 2 power n minus 2, what I can get more? N into n plus 2n is the value here. Then simplify here it is 2 power n minus 2 into here n square minus n plus 2n means n square plus n. So this is the value. So total this value is given by the value n square plus n into 2 power n minus 2. So this is also one more important point. Got it, ma? So this is the first formula, this is the second formula, and this is the third formula. So no need to remember, ma. Just you can go through the method, how you are doing that concept, that derivation. Okay, so if you remember that method, then it is okay. No need to remember all this formula. If you remember 1 plus x whole power n, if you differentiate one time, first formula. Second time if you differentiate, second formula. With the combination of these two, I will derive this formula. Sigma r equal to 0 then r square Cr is given by n square plus n into 2 power n minus 2. This is the formula. Okay, I hope that this is clear for you. Next example, listen. Now one more example here they given. Find the sum of 2 square into C naught plus 3 square into C1 plus 4 square into C2 plus so on plus n plus 2 whole square into Cn. This is the bit they given. Find the sum of, this is the value, 2 square into C naught plus 3 square into C1 plus 4 square into C2 plus 1 plus n plus 2 whole square into Cn. Listen, how you can find this total value? So this is the total value. My requirement is 2 square into C naught plus 3 square into C1 plus 4 square into C2 plus 1 plus n plus 2 whole square into Cn. This value I can write as sigma r is equals to 0 to n r plus 2 whole square into Cr. Can I mention like this? This is the nth term. 0, 1, 2, n plus third term. Okay, whatever it is. With the help of this one, can I mention like this? Just cross check one time. If r equal to 0, 2 square into C naught getting. R equal to 1, 2 plus 1, 3 square into C1. Yeah, getting. So the total sequence, what they given for my convenience with the help of sigma notation, I can write sigma r is equal to 0 to n r plus 2 whole square Cr. Then expand this value. Sigma r is equal to 0 to n. If you expand this value, r square plus 2ab means 4r plus 4 into Cr. Okay, a plus b whole square, you can get this one. Now in the next step, which is equals to sigma r is equal to 0 to n, first value r square into Cr first value plus next value 4 into sigma r is equal to 0 to n r into Cr, this is the next value, plus last value 4 into sigma r is equal to 0 to n, Cr is the value. Now which is equals to, what about this value? Sigma r equal to 0 to n, r square Cr is given by this one only. So here it is the value, n square plus n into 2 power n minus 2 plus 4 into this value. What about this value? R into Cr. This is the value, n into 2 power n minus 1 plus what about this value will be, here it is 4 into, if you expand this total value, r is equal to 0 to n. R equal to 0 to n means C0 plus C1 plus up to so on plus Cn is the value. And this is the formula in the beginning binomial coefficients already we given. This value is given by n square plus n into 2 power n minus 2 plus 4n into 2 power n minus 1 plus 4 into, this is nothing but 2 power n is the value. If you want, you can simplify by writing 2 power n minus 2 into 2 square here. This is 2 power n minus 2 into 2. Then you can common 2 power n minus 2. If you common 2 power n minus 2 among these three terms, you will get n square plus n plus here 1 2 you will get 8n you will get, here 4 you will get, 16 is the value. Then if you simplify, n square plus 9n plus n into 2 power n minus 2. Got it now? So this is the one thing which is basing on the total these three formulae. So try to remember these two only, r into Cr, r into r minus 1 into Cr, r square into Cr. If you remember these three formulae, directly you can identify this is the value, n plus 2 whole square into Cn. I hope that this is clear for you. Next. Okay, listen, even One more theorem is there. Here it is. Let me explain that one also. Here the theorem is. Next theorem. Here the theorem is, if CR denotes NCR, if CR denotes NCR, that is number of terms we are using, CR denotes NCR. Then C0 plus C1 by 2 into X plus C2 by 3 into X square plus and so on, plus Cn by n plus 1 into x power n is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. Show that our theorem of this one. One statement is given like this. If CR denotes NCR, then C0 plus C1 by 2 into x plus C2 by 3 into x square plus 1 plus Cn by n plus 1 into x power n is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. Listen all of you. Proof of this theorem. So first of all, take this given value as s. Let s is equal to, here you can let s is equal to, what is the value? C0 plus C1 by 2 into x plus C2 by 3 into x square plus 1 plus last value Cn by n plus 1 into x power n. Now that implies s is equal to, C0 means nc0 is the value. Of course nc0 means 1 is the value plus nc1 value n by 2 into x plus nc2. Here c2 means nc2. What is nc2 value? N into n minus 1 by 2 factorial means 1 into 2. Already here 3 is there. X square as it is. Guess what? What is the next term will be? C3. C3 means nc3. nc3 means n into n minus 1 into n minus 2 by 3 factorial means 1 into 2 into 3. Already in the term denominator 4 will be there. X cube plus 1. This is the value. Okay. You can mention this is the value. Now listen. In the answer, denominator n plus 1 into x is there. So what I can do? I can multiply both sides with n plus 1 into x. This total series is there now. What they given, I taken that value as s. I will get like this. But this is the theorem statement is like that. So denominator n plus 1 into x is there. So both, listen, both sides multiply with the quantity n plus 1 into x. Each and every term this side and this side also I will multiply n plus 1 into x. Then tell me what I can get. Here it is n plus 1 into x into s is equal to this value n plus 1 into x into 1, okay, plus this value n plus 1 into n by 2 means 1 into 2 I can write, into x means already x is there, you will get x square plus what is the next term? This is the next term. If you multiply this term with n plus 1 into x, what you will get? Tell me. N plus 1 into n minus 1 by 1 into 2 into 3. Already x square is there. You are multiplying with one more x. So it will change us to x cube plus 1 last value. What is the last value you will get? Here it is. Here n plus 1 in by n plus 1 into x power n plus 1. You will get this one only. Cn means 1 only, obviously. So if you multiply n plus 1 into x, already denominator n plus 1 is there. So numerator also n plus 1 you are multiplying. X power n is there. If you multiply one more x, it will change us to like this. And now listen, which is equal to this value I can written as n plus 1 c1 into x. Can I write like this now? Cross check one time. What is nc1 value? nc1. What is the value of nc1, ma'am? nc1 is equal to n only. nc1 is equal to n, or n plus 1 c1, which is equal to n plus 1. 2c1 which is equal to 2. Basing on this, there n plus 1 is there. For my convenient, I can write n plus 1 c1 into x. How I can write this value? Here n plus 1 is there. Here n is there. Means decreased by 1. Two factors are there. Denominator 2 factorial is there. So I can write n plus 1 c2 into x square plus observe this value. Starting with n plus 1, 3 factors are there. By 3 factorial is there. So how I can add this value? N plus 1 c3 into x cube. By continuing this process, last this value, you will get 1 only. That one value I can write n plus 1 c n plus 1 into x power n plus 1. So this is in the form. If you assume this n plus 1 as one n value, if you assume n plus 1 as n value, c1x plus c2x square plus c3x cube plus 1 plus it is there. What is the missing term? c0 is missing here. c0 is missing. So in the next step, what I can do? N plus 1 c0. I am adding 1. Of course, 1 I can add n plus 1 c0. Since n plus 1 c0 value 1 only. Plus what is the next value? N plus 1 c1 into x plus what is the next value, n plus 1 c2 into x square plus next value n plus 1 c3 x cube is the value. By proceeding like this, here you will get n plus 1 c n plus 1 into x power n plus 1. You are adding 1, so you can subtract 1 here. Now if you observe, what about this total value will be? If you observe till here, what is the total value will be? Conclusion I will do here. What about this total value will be? That is implies that side value n plus 1 into x into s is equal to till here, from the beginning here to here. What about this whole value? I can write as 1 plus x whole power n plus 1. Of course, last minus 1 is there, minus 1. This is nothing but binomial expansion, binomial theorem. But instead of n plus 1 is there. So 1 plus x whole power n plus 1. But my requirement is s only. So s is equal to what is the value will be? 1 plus x whole power n plus 1 minus 1 by n plus 1 into x is the value. I hope that this is clear for you. Once again I will explain. My requirement is this value. So I taken that is the value. Of course, C0 means NC0, C1 means NC1, C2 means NC2. All these things you know. But what is NC0 value? 1. NC1 value n. NC2 value n into n minus 1 by 2 factorial. X square by 3 as it is. What is the next term value will be? C3 by 4. So by 4 x cube as it is. NC3 value this one, n into n minus 1, n minus 2 by 1 into 2 into 3, so on. Now, if you observe in the theorem, they given show that this value equal this value, denominator n plus 1 into x is there. So what I did here, both sides I will multiply with n plus 1 into x. If I multiply both sides n plus 1 into x, in the first value I can get n plus 1 into x into 1 means this value plus this value n by 2 x is there. If you multiply n plus 1 into x, x square you will get. Same, everything you can multiply. In the last term, what is the last term? NCn means 1, 1 by n plus 1 is there, x power n is there. You are multiplying with n plus 1 into x, so you will get this one. Both get cancelled, x power n plus 1. Now if you observe, already we know nc1 value n, n plus 1 c1 value n plus 1, 2c1 value 2, c1 value 3, like that. So that n plus 1 value, I can add n plus 1 c1 into x. And this if you observe, two factors are there. Starting with n plus 1, two factors are there. Denominator 2 factorial means n plus 1 c2 x square. Three factors are there. Denominator 3 factorial is there. Starting with n plus 1. So n plus 1 c3 x cube. By proceeding, last value 1. That one value you can write n plus 1 c n plus 1 x power n plus 1. So if you observe this one, whole this is in the form of, if you assume n plus 1 value as n, c1 x plus c2 x square plus c3 x cube, it is there. Only one term is missing. What is the missing term? N plus 1 C naught. So add this quantity. N plus 1 C naught means 1 indirectly you are adding. So subtract last minus 1. Now from the beginning to here, if you observe, this is a binomial theorem. Of course, the power value is n plus 1. So total n plus 1 into x into s is equals to 1 plus x whole power n plus 1 minus 1 is there minus 1. But my requirement is s value only I have to find. So therefore s is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. That's it. Got it, ma? So this is the one theorem. Okay, just remember this also. Competitive exam point of view. This is also little bit important. Okay. After this, if you are interested, I hope that this is clear for you. If you can't understand, 2 or 3 times you can listen by using play and pause buttons. Okay. Next one example I will give. You can try to finish it. Okay. So here it is. If CR denotes NCR, then C0 into CR plus C1 into CR plus 1 plus C2 into CR plus 2 plus 1 plus Cn minus R into Cn is equal to 2NCn plus R. Okay. This is the next one more example. If CR denotes NCR, everywhere they are giving CR denotes NCR, CR denotes NCR. That is okay. Our aim is to find this value. Listen, ma'am. Just a hint I will give. You can try yourself. Do it 1 plus x whole power expansion. Next you can take x plus 1 whole power expansion. These two. Multiply these two. Then this side value you will get 1 plus x whole power 2n you will get it. And this side you will get here one expansion, second expansion. This is the first expansion, second expansion. First into second expansion like this. Then both sides compare coefficient of x power n plus r. You will get the result. Once again, outlook I will give. You can try yourself. 1 plus x whole power n expansion write down. X plus 1 whole power n expansion write down. Multiply these two, first bracket, second bracket. This side if you multiply 1 plus x whole power n, 1 plus x whole power n, 1 plus x whole power 2n. Then both sides you can compare coefficients of x power n plus r. Then you will get the result. Okay, try yourself anyway. If you can't get, again I will explain to you. Okay, thank you.